Welcome students. In this section we'll study about refraction. Refraction is another phenomena of light which show the bending of light when it enters from one medium to another medium. As you all know that light travels in straight line, but if anyone asks you how will you bend light, so what you will do, you will bring one plane mirror and incident light on it. The plane mirror will reflect it in the same medium. What does medium represent here? Medium is the material, air, glass, water. But if we wish to move the light downward, if I wish to move the light downward with bending, so what will I do? This can be done using rectangular glass slab. In this figure you can see that the light is incident on the glass slab. It obliquely on the surface, it enters into the glass. This is the air, the light ray is in air or vacuum. Now the light has entered into glass and at the interface it is bending through certain angle. If you look into this much portion, in air it is traveling straight, in glass also it is traveling straight, but when it enters from one medium to another, again it is emerging out into air, it is bending at the interface. This bending of light is called as refraction. So what is refraction? The bending of light ray when it falls from one medium to another medium, obliquely when it is falling, that bending is called as the refraction. Here you can see the part of light is also reflected, but we will ignore here. You can cite many examples from your daily life which shows the bending of light. This activity you might have performed in lower classes. You are having a glass filled with water, dipping a pencil in it, it bends, appears bent. This activity also you can perform. Take a glass, put a coin at the bottom of the glass and start pouring water over it. You will feel that the coin has raised. So coin appears here. This is the apparent position of the coin, but the actual position is this one. Here also the actual position of fish is here, the apparent position of fish is this one. Followed? So why this happened? This is happening due to bending of light when it is entering from one medium to another medium. And why? What is the cause for it? This depends on optical density of the medium. Optical means light, optical material, air, water. So medium, we are talking about transparent medium. So what does optical density means? It is the ability of the medium to bend the light rays. It is different from the mass density. Mass density tells you about how heavy is the object. It tells about the heaviness or the lightness of the object. It doesn't mean that if optical density is more, the material is heavy. As you all know that when you are in a glass, you are having water and pour some oil over it, oil starts floating over water. This shows that oil is lighter than water. But if you talk of optical density, the optical density of oil is more than the optical density of water. So the amount of bending of the light depends on which property? Optical density of the material. I have performed one activity. You can also do it at your home. Take a paper, mark this arrow and see through the glass which is empty. Now pour some water in it. The direction of the arrow is changing. This is due to the bending of light ray. So what this bending called? This is the refraction of the light. How can you define refraction of the light? When light travels obliquely from one transparent medium to another, it gets bent. This bending of light called as refraction. Here, what do you mean by obliquely? Means it is falling at certain angle. from one transparent medium, that is air to water or air to glass. Air is a rarer medium and glass or water is denser medium. So whose optical density will be more? Glass. The optical density is more, so amount of bending is more, it is bending towards the normal. So what is refraction? How it occurs, how refraction occurs. So here in this ray diagram you can see that when the light rays are traveling from rarer to denser, it is bending toward the normal. This is the angle of incidence and this is the angle of emergence. In this case, angle of incidence will always greater than angle of emergence. In this ray diagram, you are observing that the ray of light is entering from denser to rarer. So this is the refracted ray, it is bending away from the normal. Here this is the angle of incidence, this is the angle of refraction. In this case, angle of incidence will be less than angle of refraction. Followed? So this bending, again this bending is due to what? What is the cause why this bending occurs? This is due to change in the speed of light when it enters from one medium to another medium. You all know what the speed of light in air or vacuum is 3 into 10 raised to power 8 meter per second, and the speed of light in glass is 2 into 10 raised to power 8 meter per second. So when it enters from air to denser medium, what will happen? It will change the speed, so it will move fast, it will take the shortest path, so it will bend towards the normal. You know that light is always in hurry, it always takes shortest path. So here it is moving from denser to rarer, the speed of the light increases, it bends away from the normal. So that's why this angle of refraction is greater than angle of incidence. So till now we have studied what is refraction. It is the bending of light ray when it travels obliquely from one medium to another medium. Then how it occurs? When it is moving from rarer to denser, it bends towards the normal. When it bends moving away denser to rarer, it will bend away from the normal. And what is the cause? Why it happens? It is due to the change in the speed of light. Now suppose you are having a glass slab and rectangular glass slab, and the light rays are falling normally on this. What will happen? It will pass through the glass slab without bending. Here angle of incidence is equal to 0, angle of refraction is also 0. Here also the speed of light changes, even then it passes straight through the glass slab. It means what is the condition for refraction? That light rays to fall should fall obliquely on the surface, transparent medium. Now you have to trace a path of light through a glass slab. This you will do in your laboratory. Take a glass slab, marks its boundary on a white paper, put it on the white paper, marks the boundary, draw a normal, and at certain angle pricks two pins so that this is the angle of incidence, and looking on the opposite side prick two more pins so that all the 4 pins are on the straight line. So here this is, and if you join these 2 points, this is the refracted ray. Measure angle I, angle R and angle E. This is the angle of emergence. So the amount of bending in this, when it is entering from one medium to another medium, here it bends, and by the same amount it bends this way. So that's why angle of I is always equal to angle of emergence. If you extend this original incident ray backward, you will find that this incident ray is parallel to the emergent ray. It is always parallel, and the perpendicular distance between this incident ray and this emergent ray is called as the lateral displacement. There is lateral shift in the path of the light. Followed, this shift is called as the lateral displacement. So draw this ray diagram and mark incident ray, angle of incidence, point of incidence, normal, angle of refraction, refracted ray, emergent ray, angle of emergence, and lateral displacement. Now we'll study how it depends, what are the factors on which the lateral displacement depends. It depends on the thickness of the glass. thickness of the transparent medium. If thickness is more, lateral displacement will be more. It also depends on the angle of incidence. It also depends on angle of refraction, and both is called the relationship between sin I upon sin r. It is another value called as the refractive index. Followed. So as the thickness of the glass increases, the lateral displacement will be more. Now as you have studied about the here some questions related to lateral displacement. Just now we have discussed what will happen when it falls normally. It will pass straight through the glass slab. What happens, what is lateral displacement, and on what factors does it depends. Here you can see that the speed of the light in air is 3 into 10 raised to power 8 meter, water 2.25, glass 2.8, diamond 1.2. Very less speed in diamond, that's why the amount of bending will be maximum over here. Now you have studied about the laws of reflection. Here you will study about the laws of refraction too. First law is that the incident ray, normal and the refracted ray, they lie on the same plane at the point of incidence. Now there is some relationship between angle I and R. Here you have seen angle I is never equal to angle R, but still how they are related? The ratio of sin I upon sin R is constant. This constant is called as the refractive index and it is denoted by N. This law is called as the Snell's law. This N is also equal to the ratio of the velocity of light in one medium to the velocity of light in another medium. Now what is refractive index? It is the property of the transparent medium which is equal to, it is constant. This is the constant value which is equal to the ratio of sin I upon sin R. And this N is also equivalent to the ratio of velocity of light in first substance to the velocity of light in second substance. So what is refractive index? It is the amount of bending of the light in between two given substances and it is represented by N. If refractive index is more, amount of bending will be more. Where sin I represents sine of angle of incidence, sin R represents sine of angle of refraction. In numerator always we take air or vacuum, and in denominator we take the material which is to be investigated. Next, again few questions. What is lateral displacement? On what factor does it depend? On what factor it depends? Lateral displacement depends on the thickness of the glass slab. It also depends on the refractive index. Refractive index depends on what values? Angle of incidence and angle of refraction. How it depends? Lateral displacement. If the thickness is more, the lateral displacement will be more. Now here few values are given. From here you can find out that the optical, these are the refractive index. If optical density is more, refractive index is more. 1.43 paraffin oil, 1.47 turpentine oil, 1.34 water. Here you can easily differentiate between the mass density and the optical density. What happens when you put turpentine oil over water? It will float. It means oil is lighter than water, but from this value you can find out that the optical density of oil is more than that of water. So if optical density is more, it doesn't mean that it is more heavy also. Now few questions before ending up. The refractive index of diamond is 2.42. What is the meaning of this statement? This suggests that from this relation you know V is equal to C by N. What is V? Velocity, speed of light in the medium, and what is C? Speed of light in air. N is the refractive index. So the value of N is 2.42. So the speed of light in diamond comes out to be 1 by 2.42 times that of the speed of the light. Next question, how should a ray of light be incident? so that it comes out without bending, without displacement. You have already studied, it should be falling normally on the surface. Next question, a ray of light traveling in air enters obliquely into water. This is water. Normal ray of light is entering into water. What will happen? On entering into water, it will bend towards the normal. So does the light ray bend towards the normal or away from the normal? Towards the normal. Why? Because the speed of light in water is less than the speed of light in air. You have to show with the help of this ray diagram. Next question, a ray of light enters a rectangular glass slab with refractive index 1.5 and it emerges out of the opposite face of the slab without being displaced. If its speed in air is this much, what is the speed in glass? So again, using this formula, V is equal to C by N, you can find out the value comes out to be 2 into 10 raised to power 8 meter per second. Next question, the speed of light in a transparent medium is 0.6 times, that is that of its speed in vacuum. So what is the refractive index of the medium? So V is the speed of light in the medium, C is the speed of light in the air, N is the refractive index. So N is equal to what? C by V. C and V is given 0.6 times of C. So C cancel, you get 1 by 0.666. So this value comes out to be 1.67. So that's all for in this section. In next, we'll deal with the spherical lenses and the refraction through the spherical lenses. Thank you.